In this video, we'll explore how to find the final temperature in a thermochemistry experiment using a graphical method. Start by tabulating your data for your experiment. Here we have data recorded. Notice a few data points that seem to have taken place before any reaction took place. At 120 seconds, the reaction starts. Perhaps we mixed two things together at 120 seconds, and we notice that slowly the temperature rises to a large maximum, 45.6 degrees, and then stays relatively linear for a certain amount of time before then cooling down again. Looking at it graphically, we see exactly the same thing. We see our before temperature, so perhaps this is T initial in a reaction that's taking place. At 120 seconds, right around here, we've mixed our reactants together. We've started the reaction. The temperature begins to rise. In this region, we have our temperature relatively consistent, though it is decreasing slightly. And then over here, we start to cool down towards room temperature again. Our goal is going to be to extrapolate these points over here back to the mixing time or the reaction time and find Tfinal over here. There are a couple of ways to accomplish this. One way is to do this graphically, and that means we can just plot the data that we care about, in this case starting around here, 45.6 Celsius, and going till here around 45.3 Celsius. We only include this data because we haven't reached a maximum here, and here we started cooling, so this is the linear region, these points over here, in which we see the temperature has stabilized but started to cool slightly. Alternately, and I think this is a little bit more elegant, subtracting 120 seconds, being the time where the reaction began, from all of the times, what we get is now the time where the reaction begins is called time zero, and if we were to extrapolate our line backwards to T0, we would get the temperature, or the final temperature, at the beginning of the reaction. Now, we're not going to extrapolate all the points. If we were to include all of these points, you would see we'd get a very weird line. In fact, we can see that right here, so we're going to insert chart here just to show us. Right, this line, if we were to draw a trend line on this line, you'd see that the trend actually decreases and goes down, and so that wouldn't give us a meaningful value over here. What we want to do is we want to include only these points. So let's graph these points, and we see that we have a line that's increasing slightly. Taking the trend line of these points, we see that a final temperature over here, 45.771 degrees, which is the time where, or the temperature where this line intersects the initial mixing time. If you don't want to do it with the graph, you don't have to. Excel has a really neat feature called the intercept function, and that intercept function allows us to select a number of y points and x points. Again, we're only going to select the points that we want to extrapolate backwards, and this gets us our y-intercept at that mixing time here, 120 seconds, or our scaled mixing time of 0 seconds. So I hope this has been useful and that you can use it to find Tfinal in thermochemistry experiments.